September 1942, 4 aircraft built from wood scream across the North Sea. They fly so low their propellers seem to clip the tops of the waves, a desperate tactic to stay below German radar as they head for occupied Norway. Their target? The Gestapo headquarters in the heart of Oslo. The mission? An 1,100-mile round trip, almost entirely over hostile territory. And the defenders waiting for them? They weren't just any pilots. They were Germany's elite fighter unit, equipped with the Focke-Wulf 190, one of the deadliest and fastest aircraft in the entire Luftwaffe. The moment the wooden planes are spotted, German interceptors scramble into the sky. It doesn't take long. They close in on one of the British aircraft, a predator locking onto its prey. Cannon shells rip into the fuselage. The British pilot thinks it's flak from the ground until his wingman pulls up alongside him, frantically gesturing. He looks back. A Focke-Wulf 190 is glued to his tail. There's only one thing to do. Squadron leader Perry slams the throttles wide open and dives, hurtling into the twisting Norwegian valleys. The powerful German fighter tries to follow, but it can't keep up. The wooden plane is simply too fast, too nimble. It vanishes. 3 of the 4 aircraft escape. They fly 1,000 miles back home, across a continent controlled by their enemy. When the report reached German high command, they were in disbelief. These British aircraft, they were made of plywood. They were being built in piano factories. And yet, somehow, they were faster than the Luftwaffe's finest fighters? It was a mystery that infuriated them. When they finally captured one, after it made a wheels-up landing, German engineers swarmed over it like ants. They examined every inch of the strange wooden airframe. They discovered a sophisticated sandwich of materials Germany simply didn't have. They carefully removed its powerful Rolls-Royce Merlin engines and ran them on their own test beds. And that's when they finally understood. That's when they discovered exactly why their fastest fighters couldn't catch it. This is the story of the Havilland Mosquito, the wooden wonder that made the head of the Luftwaffe, Hermann Göring, turn green and yellow with envy. To understand the Mosquito, you have to go back to 1940. Britain stood alone against the might of the Nazi war machine. German bombers had spent months turning British cities to rubble during the Blitz.
The Royal Air Force was fighting for its very survival, and it desperately needed new aircraft. But there was a problem, a huge one. Aluminum, the essential material for building modern planes, was in desperately short supply. Every last scrap of metal was being funneled into building Spitfires and Hurricanes to defend the skies. Bomber Command needed a new, fast bomber, but the Air Ministry was stuck in the past. They insisted any new bomber had to have heavy gun turrets, defensive armor, and a 3rd crew member to operate the guns, all of which made a plane heavy and slow. But one man, a brilliant aircraft designer named Geoffrey de Havilland, had a different idea. It was a revolutionary idea, an idea the Air Ministry thought was completely, utterly mad. On the 1st of January 1940, he made a bold declaration. He proposed an aircraft that would be the fastest bomber in the world, so fast it would need no defensive guns at all. Its speed, and its speed alone, would be its armor. And then came the most shocking part of his proposal. It would be built almost entirely from wood. The Air Ministry was horrified. Wood? In 1940? This was the age of sleek metal monoplanes. Wooden aircraft were relics of the Great War, not tools for this new modern conflict. They demanded he add gun turrets. They demanded a 3rd crewman. They demanded a conventional metal design. De Havilland refused. In a letter, he laid out his vision. A twin-engine bomber with performance so outstanding that little defensive equipment would be needed. No turrets, no extra crew, no heavy armor. Just 2 crew members, 2 powerful engines, and pure, unadulterated speed. The Minister of Aircraft Production, the powerful Lord Beaverbrook, was even more dismissive. He contemptuously nicknamed the project Freeman's Folly, after the one senior officer, Air Vice Marshal Wilfred Freeman, who championed the idea. In June 1940, with the Battle of Britain raging, Beaverbrook ordered all work on the project to stop. Britain, he insisted, needed to focus on 5 proven aircraft, the Spitfire, Hurricane, Wellington, Whitley, and Blenheim. There were no resources to be wasted on some madman's experimental wooden airplane. Even the Americans, Britain's future allies, were skeptical. They sent engineers from Beech Aircraft to look at the plans.
Their verdict was brutal. They concluded the design sacrificed serviceability, structural strength, ease of construction, and flying characteristics just to use a material that was not suitable for the manufacture of efficient airplanes. The project should have died right there, scrapped, forgotten, a footnote in history. Instead, something very British happened. Air Vice Marshal Freeman, the plane's champion, received Beaverbrook's shutdown order and conveniently ignored it. He quietly ensured the project was classified as a special case that didn't need ministerial approval. De Havilland, equally determined, started funding the development out of his own pocket. Work continued in secret, hidden away in a small, disguised building at Salisbury Hall. On November 25, 1940, the prototype, W4050, was rolled out onto the runway at Hatfield Aerodrome. Jeffrey de Havilland Jr., the founder's own son, sat in the cockpit. He pushed the throttles forward, and the wooden aircraft surged into the air. It climbed away smoothly. Everything worked perfectly. But the real moment of truth came on January 16, 1941. The prototype was put to the ultimate test, a head-to-head race. Its opponent was a Spitfire Mark II, the legendary fighter that had just won the Battle of Britain, the pride of the RAF. Surely this icon of British air power would humiliate the strange wooden bomber. The two planes flew side by side in level flight at 6,000 feet. Then they opened their throttles. The Mosquito didn't just win, it flew past the Spitfire as if it were standing still. 392 miles per hour versus the Spitfire's 360. The wooden bomber was faster than Britain's finest fighter. After that, the critics fell completely silent. Freeman's Folly was suddenly looking like Freeman's genius. But what made this wooden aircraft so remarkably fast? The answer lay in incredibly sophisticated engineering that looked primitive but was anything but. The fuselage wasn't just plywood, it was a composite sandwich. Imagine two thin outer skins of Canadian birch plywood, each just 3/32 of an inch thick. Between them was a core of Ecuadorian balsa wood, a material famous for being incredibly light yet strong. The entire sandwich was just over half an inch thick, yet it was immensely strong, rigid, and perfectly smooth. The wing was another masterpiece. It was built as a single structure, from one wingtip all the way to the other, with no weak joints at the fuselage. Holding it all together wasn't just glue. There were approximately 30,000 tiny brass wood screws reinforcing the joints in the wing alone, with another 20,000 in the fuselage and tail. And the glue itself was a technological marvel. The British had perfected a synthetic resin adhesive called resorcinol. This stuff was a game changer. It was stronger than the wood it bonded, it didn't corrode, and it maintained its incredible strength in all weather conditions, from the freezing altitudes over Germany to the humid jungles of Burma. The Germans, as they would later discover to their cost, had nothing like it. This construction method was also brilliant for manufacturing. Instead of relying on overworked aircraft factories, de Havilland turned to Britain's furniture industry. Skilled craftsmen in places like High Wycombe, who had been making chairs and tables, were now building wings and fuselages. Multiple production lines could run in parallel. At its peak, a single factory could produce a Mosquito every single day. And this wooden construction had a hidden aerodynamic benefit. Metal aircraft were held together by thousands of rivets, and each rivet head created a tiny bit of drag, disrupting the smooth flow of air over the wings. The Mosquito's plywood skin, by contrast, was glass smooth. This alone added precious miles per hour to its top speed. Every single detail was obsessed over to reduce drag. The radiators, for example, weren't slung underneath the fuselage like on a Spitfire. They were cleverly built into the leading edge of the wing. Providing the power were two magnificent Rolls-Royce Merlin engines. These 27-liter V12 power plants were legends in their own right. They were actually smaller than their German counterparts. The Daimler-Benz 601 was 36 liters, the BMW 801 was 42 liters, but the Merlin was far more efficient, producing equivalent or better power with less weight and lower fuel consumption. Later versions of the Mosquito got the Merlin 61, with a revolutionary two-stage, two-speed supercharger that dramatically boosted high-altitude performance. With these engines, the Mosquito could hit a staggering 439 miles per hour. De Havilland's original theory had been simple and elegant. He reasoned that if you took a design with roughly twice the surface area, twice the weight, and twice the power of a Spitfire, it should, logically, be about 20 miles per hour faster. The actual result blew his predictions away. The Mosquito was over 30 miles per hour faster than the theory suggested, a testament to its stunningly superior aerodynamics. On September 17, 1941, the first operational Mosquito sortie was launched. Squadron leader Clark flew a photo reconnaissance mission over the French coast. He was intercepted by 3 Messerschmitt 109s at 23,000 feet. He didn't dogfight, he didn't dive, he simply pushed the throttles forward and flew away from them. This would become a very familiar pattern. By early 1942, the Germans realized they had a serious problem. Mosquito reconnaissance aircraft were penetrating deep into the heart of the Reich, photographing sensitive targets with complete impunity. Fighters would scramble to intercept them, but they just couldn't catch them. Then, on September 19, 1942, came an even greater humiliation. A lone Mosquito appeared over Berlin, in broad daylight. It was the first Allied aircraft to do so since the war began. Messerschmitt 109s clawed into the sky, their engines screaming at full throttle. The wooden aircraft simply flew away from them, as if they were barely moving. But the mission that truly cemented the Mosquito's legend, the one that struck a devastating psychological blow, came on January 30, 1943. This date was the 10th anniversary of Adolf Hitler's rise to power. The Nazis had planned massive nationwide celebrations. Hermann Göring, the head of the Luftwaffe, was scheduled to deliver a live radio address to the nation in the morning. Propaganda Minister Joseph Goebbels would speak that afternoon. The entire Reich would be listening. At exactly 11 a.m., 3 Mosquitoes from 105 Squadron arrived over Berlin. They dropped their bombs with precision right on the main broadcasting station, just as Göring began to speak. His speech vanished from the airwaves. German radio went dead silent for over an hour. Göring, the flamboyant, boastful leader of the world's most feared air force, was publicly humiliated, silenced by 3 wooden airplanes. He was boiling with rage. That afternoon, it happened again. 3 more Mosquitoes, this time from 139 Squadron, arrived just as Goebbels was beginning his speech. Once again, bombs fell on Berlin. Once again, the Nazi leadership was made to look foolish and impotent in front of their own people. The psychological impact was devastating. Back in 1939, Göring had famously promised the German people that no enemy bomber would ever reach the Ruhr industrial region. "If one should reach the Ruhr," he boasted, "my name is not Hermann Göring. You can call me Meyer." After the Mosquito raids, Germans mockingly started calling him Meyer. They called the air raid sirens Meyer's trumpets. His credibility was shattered. On March 18, 1943, a furious Göring summoned Germany's top aircraft manufacturers to his lavish hunting lodge at Karrenhall. Professor Willy Messerschmitt was there, Dr. Ernst Heinkel was there, Field Marshal Erhard Milch was there. A stenographer recorded every single word of Göring's 6-hour tirade, and what he said that day would become the most famous acknowledgement of British technological superiority by any German commander in the entire war. "It makes me furious when I see the Mosquito," Göring raged. "I turn green and yellow with envy. The British, who can afford aluminum better than we can, knock together a beautiful wooden aircraft that every piano factory over there is building, and they give it a speed which they have now increased yet again." He continued, warming to his theme. "The British built a wooden aircraft at the right moment, which is almost incredibly superior and unrivaled in speed. Today, these aircraft stooge back and forth over Germany, carrying out very heavy attacks without incurring the slightest loss." Turning to Professor Messerschmitt, he added with heavy sarcasm, "Everyone should come and look at this amazingly primitive aircraft. Then they might learn something. Why spend any more time searching? Let us build the Mosquito. That is the simplest thing we can do." But the Germans couldn't build the Mosquito. They would try, and they would fail catastrophically. By mid-1943, the Germans had managed to capture exactly 1 intact Mosquito. The aircraft had made a wheels-up forced landing somewhere in occupied territory. It was given the German code T9 plus XB. German engineers descended on it. The landing gear was destroyed, the propellers were shattered, the fuselage was structurally damaged. The plane would never fly again. But they could study it, they could see how it was made. They were astonished. The plywood-balsa sandwich was beautifully engineered, but it used materials Germany couldn't get. The British had access to Ecuadorian balsa wood, Canadian birch plywood, and Sitka spruce from North America. Germany, under a tight naval blockade, had none of these in adequate supply. They carefully removed the Rolls-Royce Merlin engines and tested them. The power output was remarkable, the fuel consumption impressively low. The design was more sophisticated than their own. But most importantly, they discovered the Mosquito's secret electronic advantage. At an Air Ministry meeting on the very same day as Göring's famous outburst, the Luftwaffe's head of radar technology reported that the Mosquito was considerably harder to pick up than metal aircraft were. The wooden construction gave only a weak radar signal. This explained everything. German radar, the first link in their entire air defense chain, could barely track the Mosquitoes. German fighters needed that radar guidance to find their targets in the vast dark sky. The system was failing at the very first step. The captured aircraft, T-9 plus XB, was never flown by the Germans. It was listed in their records as unserviceable. For propaganda photos, they cobbled together a crude steel tube undercarriage and put it on public display. But it was a hollow victory. This was the only intact Mosquito they would capture in the entire war. Out of thousands of missions over Europe, just one broken aircraft that couldn't even fly. And they didn't need to fly it to know they were in deep trouble. The combat record was making that painfully clear. In its first 600 bombing missions, exactly one Mosquito was lost. 1 in 600. The overall loss rate for Mosquito bombers across the entire war was just 0.7%. To put that in perspective, heavy bombers like the Lancaster suffered 2.2% losses. Some Lancaster squadrons lost 5% or more of their aircraft on a single mission. The Mosquito was losing less than one aircraft for every 140 missions flown. During the brutal Battle of Berlin from late 1943 to early 1944, the numbers were even more stark. The Lancaster loss rate was 5.1%. The Mosquito loss rate was 0.5%. The heavies were being slaughtered. The Mosquitoes were virtually untouchable. Post-war analysis showed the Mosquito was nearly 5 times more cost-efficient than the Lancaster in terms of useful damage delivered per pound spent. So why couldn't the Germans shoot them down? It came down to performance. The most common German fighter, the Messerschmitt 109G, had a top speed of 391 miles per hour. A Mosquito Mark 9 could do 405. The Focke-Wulf 190 was even worse at the high altitudes where the Mosquitoes operated. Eventually, late in the war, in September 1944, the Germans introduced fighters that could finally match the Mosquito's speed. But by then, the Mosquito had been operating over Germany with impunity for 3 long years. It was too little, too late. Even Germany's wonder weapon, the Messerschmitt 262 jet fighter, wasn't a silver bullet. Yes, it was over 100 miles per hour faster, but the jets came too late, in too few numbers, and were plagued by unreliable engines. And the sheer speed of the jet made it incredibly difficult to get an accurate shot at a fast-moving Mosquito. One American Mosquito pilot, Lieutenant Richard Kenny, described evading 2 Me-262s. He rolled, dived, and jinked violently, never flying straight, preventing the jet pilots from getting a clean shot. Finally, one of the German jets pulled up alongside him. The pilot simply waved his hand in frustration, then turned for home. Even a jet fighter couldn't guarantee a kill against a well-flown Mosquito. The Germans tried everything. They formed special elite squadrons tasked specifically with hunting Mosquitoes. They failed. German night fighter pilots became so unnerved they coined a special term for their fear, Mosquito-Schreck, the Mosquito terror. The mere rumor that Mosquitoes were in the area was enough to make some German pilots want to land immediately. Mosquito night fighters, in turn, claimed around 600 Luftwaffe aircraft shot down over Germany, often ambushing them as they came into land. Meanwhile, the Germans desperately tried to copy the design. The project was called the Focke-Wulf Ta-154, and it was even unofficially nicknamed the Mosquito. The prototype flew in July 1943 and was competitive with the British original. It seemed Germany finally had an answer. But the Ta-154 had a fatal flaw. It relied on a special phenolic resin glue made at a single factory in Wuppertal. In a moment of supreme irony, RAF mosquitoes bombed and completely destroyed that factory. The Germans tried to make a substitute adhesive, but it was corrosive. It literally ate away at the wooden structure of the plane. In July 1944, during a test flight, a Ta-154 using the new glue suffered a catastrophic structural failure. The wings disintegrated in midair. The entire project was cancelled. Germany's copy of the Mosquito was doomed because they couldn't replicate the British glue. The Mosquito's versatility was as remarkable as its speed. The same basic airframe served as a bomber, a fighter, a pathfinder marking targets for heavy bombers, a photo reconnaissance aircraft, a night intruder, a fighter bomber, and an anti-shipping strike aircraft. They flew some of the most daring and precise raids of the war. In Operation Jericho, they blew open the walls of Amiens prison to free French resistance fighters. In another raid, they flew at rooftop height to destroy Gestapo records in The Hague, dropping bombs through the doors and windows of a single building with zero collateral damage. In the final months of the war, the light night strike force of Mosquito bombers maintained relentless pressure on Germany every single night, especially when bad weather grounded the heavy bombers. From January to May 1945, they dropped over 1,400 massive 4,000-pound cookie bombs on Berlin alone. The city's air raid sirens wailed multiple times, every single night. The psychological pressure was immense. In total, almost 7,800 Mosquitoes were built. They served in 20 air forces around the world. One particular aircraft, known as F for Freddy, flew an incredible 213 operational sorties, more than any other Allied bomber in the war. When the war finally ended, the Mosquito had achieved something every military designer dreams of. It had achieved complete dominance in its role. Its loss rate was so low it was effectively sustainable forever. Its performance was so superior the enemy could not counter it. And its versatility was so great it could fill a dozen different roles. Hermann Göring's words from his hunting lodge remain the ultimate verdict. "The British," he raged, "have the geniuses, and we have the ninnies." It was an exaggeration, of course. German engineers were brilliant, but it captured an essential truth. Britain, with its furniture factories and plywood, with its superior engines and advanced adhesives, with one man's stubborn vision and another's quiet insubordination, had created something truly extraordinary. The Germans had metal, they had sophisticated engineering, they had some of the finest designers in the world, but they could not match a plywood and balsa sandwich held together with glue. When they captured one, they found materials they couldn't get, technology they couldn't replicate, and performance they couldn't believe. When they tried to copy it, their own version fell apart in the sky.
When they sent their fastest fighters to intercept it, the Mosquito simply flew away. This was the aircraft dismissed as primitive, built by piano makers, that made the Luftwaffe's finest pilots feel terror, made Germany's greatest commanders feel incompetent, and made the head of the Reich's Air Force turn green and yellow with envy. It was a wooden wonder that proved that sometimes clever innovation, radical thinking, and sheer breathtaking speed can triumph over brute force and industrial might. The Mosquito wasn't just an aircraft, it was a statement.